previous lecture, I talked about forecasting errors. We have learned three forecasting methods: moving average, weighted moving average, and exponential smoothing method. Besides, there are many other methods that we can learn and talk about. The question is, which is better that, than the other? How can we tell that a forecasting method is more accurate or working better than the other methods? We define forecasting as the art and science of predicting a future event, and it's imperative to know which model is working better than the others. In this sense, we need a tool or measure to tell the efficiency of a forecasting model. We will learn forecasting errors in this lecture. Forecast error is defined as the difference between actual demand and forecast value. In other words, the deviation from the actual demand data. And notice that we are going to take the absolute value of the difference between actual demand and forecast value. Because deviation could be either positive or negative, and when there are positive and negative together, the error could disappear. So we want to take absolute value so that we can preserve forecast errors. Good forecasting reduces forecasting errors as much as possible. There are three measures of forecasting errors that deal with this. They are mean absolute deviation and mean square error, MSE, and mean absolute percent error. First, let's talk about mean absolute deviation, MAD or MAD. MAD sums the absolute difference between actual demand and forecast and divide it by the number of periods. It's quite straightforward method used in forecasting. The second method is mean squared error or MSE. MSE is defined as the sum of forecast error squared divided by the number of period. Why do you think this formula squares forecast errors? It is to amplify the forecast errors so that it's easier to tell which forecasting model is better than the others. Right? If you square it, it amplifies the error, and you want to see which one is better than the other. The third method is mean absolute percent error. As the name suggests, mean absolute percent error calculate the percentage of the forecast errors. It is often difficult to interpret MAD and MSE, and they are scale dependent. However, MAPE is easy to understand because it just tells you that the model is some percentage off from the real data. If you are comparing accuracy across the time series forecasting models with different scales, you can't use MSE. For business use, however, MAPE is often preferred because apparently managers understand percentages better than squared errors or mean absolute deviation. MAPE can be used when percentages makes no difference. For example, the Fahrenheit and Celsius temperature scales have relatively arbitrary 0 points, and it makes no sense to talk about percentages. MAPE also cannot be used when the time series can take zero values. However, as you can see, it's much more complicated to calculate MAPE, but it's much easier to interpret. Now, in this example, say you are using exponential smoothing method for tonnage demand. You have 8 quarters and actual tonnage data has been recorded. The alpha you want to use is 0.1 and 0.5 in this case. In using this formula of exponential smoothing method, you want to calculate the forecasting first and then create forecast errors for each model, and then find out the error measures for MAT and MSE and MAPE. That's what we are going to do in this lecture. So first, let us calculate the forecast model with alpha zero point 0. If you plug in these numbers, you'll find these forecast errors. You do the same thing with alpha equals zero point 0.5 and you find the forecast values. And then now your job is to find forecast errors. And forecast errors are defined as the absolute difference between actual demand and forecast value. So using that formula, you calculate forecast errors for each row. For example, for the first column, for first model, alpha equals zero point 0, you have 5 because the absolute difference between 180 minus 175 is 5. Similarly, 168 minus 175.5 is 7.5. Although it's negative, we took absolute value of that, so that's why it's 7.5. Similarly, you can do the same thing for the second model with alpha is zero point 0.5 and then calculate MAT or forecast error, and here's the result. Then now you're ready to calculate MAD and MSE and MAPE. So let us do that. So the straightforward one is MAD. MAD is simply the summation of deviations and divided by number of period. So in this case, 82.5, which is the sum of the deviations, and divided by 8, which is the number of quarters included in this model. And you have 10.31 as a MAD. You do the same thing for second model and you get 200.33. Now you compare 10.31 and 12.33, which is lower, 10.31, right? So you want to choose first model because that's producing less error for this forecasting. What about MSE? In this case, you want to square the forecast errors, add them up, and divide the total by the number of period. For the first method, it's 190.82, and for the second one, it is 195.24. MSE is lower for the first model. Thus, the first model is better than the second model. As for MAPE, if you go through the calculation, you will find that alpha is when alpha is 0.0, it's only 5.59%, but when alpha is 0.50, the maybe is 6.76%. So it's much easier to interpret, and you can clearly tell the first model is lower, producing lower errors than the second model. Taken together, in all three forecast error measures, the first model is more reliable and accurate than the second model, right? So these are lower than this, so that's why first model is better. Thus, you can choose the first model and use it for your forecasting. In summary, this lecture discussed the importance of forecasting and several methods to forecast. And we really need to distinguish which one is better than the other, and forecast error is telling us the information. And here in this case, we learned MAT and MSE and MAP for the method, and after calculation, you want to opt for the one with the lowest error.